Okay, so this is lesson 6.8. Basically what it is, it's logs and exponentials in word problems, okay? See inside that box, you guys, that a of t is equal to a sub 0 e to the kt. So that formula looks like scary. Underneath it, I want you to write a equals p e to the rt. That's all that is. And we've done that before, okay? So a is the new amount. See that a sub t? I want you to change that to new amount. The p, which is the a sub 0, is how much you start with. You guys know e is 2.7. It's just a constant. R is a rate. That's the same thing as your k. So if k is negative, the amount is going down. If k is a positive, the amount is going up. And t is always time. Okay, so this is no different than the formula that you used on the money problems. It's exactly the same. Okay, so let's start with question 1. Okay, the size p of a certain insect population at time t in days obeys this function. Okay, all that means is it follows the function. Okay, so you've got your t, which stands for time, and then everybody just write down that p of t stands for population. And maybe in front of that p of t, call it a y, okay? Because it's solved for p of t, so p of t is y. What is the initial number of insects? That's when 0 days have passed. Well, guys, you can look at the formula and see the initial amount. The initial amount is right there. So that would be 300 insects, okay? You can literally just do that and you're totally good. I do want you to write this down, though. Everybody go p of 0 is equal to 300e to the 0.15 times 0. Okay, now you could totally put this in your calculator, but just stop for a second and think about it. Look, you guys, 0.15 times 0 is 0. E to the 0 is a 1. 1 times 300 is 300. Okay, so you don't have to show work on this, but that's how you could figure it out with the formula. Okay, what is the population after 20 days? So guys, everybody look right here. The 20 is either going to go right here for t, or it's going to go right there for p of t. Well, p of t is the population, so it wouldn't go there. It's got to go into t. So everybody go p of 20 is equal to 300 times e to the 0.15 times 20. Okay, now grab your calculator. And everybody go 300 second ln 0.15 times 20, close it off, hit enter, and we're going to round this to the nearest whole. So it's going to be 6,026 insects. Make sure you label it, okay? So the number is a point and the label is a point. So you've got to make sure you get both of those, okay? When will the insect population reach 600? Everybody in the room tell me, okay, I want you to talk to me right now, guys. Do I put the 600 in for t, or do I put it in for p of t? Everybody tell me. P of t, good. Okay, so everybody go 600 is equal to 300 e to the 0.15 times t. Okay, I want you to freeze right there. Okay, everybody just freeze for a second. I'm solving for t. My t is stuck in the exponent. There's only one way to get it down. What am I going to do to get that out of the exponent? Say it again, Sam. You're going to have to convert it. Yes. Do I convert it right now? Tell me that. Why don't I convert it now? Because I'm not stuck, right? So what do you have to do? Get rid of that 300, right? So now I have e to the 0.15 t is equal to 300 divided by 600, which is 2. Am I stuck now, everybody? Yes, so now I convert it. So it's log base e of 2, that's ln 2, is equal to 0.15 t. To solve for t, you divide, so it's ln 2 divided by 0.15. Okay, grab your calculator and go ln 2, close it off, divided by 0.15, hit enter. Okay, this is all going to be in days. Let's say that the directions told you to round to 2 digits. On the test, I'll totally tell you what to round. So it would be 4.62 days. Now, box your answer, but don't clear your calculator. Okay, you guys, so many of these questions are checkable. Look what I want you to do. I want you to hit store enter. Then look right here, see what I'm highlighting? If you put that in your calculator, and wherever you see a T, you put in that stored value. If you get 600, you just checked it. We can check this thing in 15 seconds. So you go 300, second, ln, 0.15, membar, enter, close it, enter, 600, bam, check that. So please make sure that you check it. I know time was an issue on quiz 3, okay? I apologize about that. I've edited test 3, I feel like it's ready, but I also feel like it's too long. So I'm going to go through and I'm going to get rid of some of the problems, so then hopefully we won't have that same problem. Okay, so I know it was tight and I'm sorry. Okay, when will the population triple? You guys listen, you have to decide what variable you're looking for. Are we looking for P of T, which is population, or are we looking for T, which is time? Everybody tell me. We're looking for time, right? So everybody go 300 e to the 0.15 t. I'm looking for t. The second I write that down, I know I'm going to have to convert eventually. Okay, not right now necessarily, but I have to get that t out of there. I have no more numbers to work with. Someone tell me what to put on the other side. Yeah, some of you guys are putting 3 because triple means 3 times, right? But if you start with 300 and it triples, now you're at 900. Okay, what am I going to ask you right now? Everybody tell me the question. Are you stuck? What's the answer to the question? No, what do you do? Divide by 300, right? So you have e to the 0.15t is 900 divided by 300, which is 3. Now I'm stuck, so I convert it. So it's log base e of 3, that's ln 3, is equal to 0.15 t. To solve for t, divide, so it's ln 3 divided by 0.15. Grab your calculator. Everybody go ln 3, close it off, divided by 0.15, hit enter. Let's go 2 digits again, the directions will tell you. So it'd be 7.32, and this is all in days. Make sure you label it. Okay, now everybody hit store, enter. Put it into the purple right there, the right hand side of the equation we set up. So go 300, second, ln, 0.15, membar, enter, close it, enter. Got it right. No question. Okay, who says I'm good? Easy. Okay, great. Okay, let's keep going. Question 2. Let Y represent a mass of radioactive strontium in grams. The quantity of strontium present after T years is given by this equation. Okay, everybody go T equals and Y equals. Okay, remember on test 2, some of you we were doing word problems and you didn't write that down and then you started getting mixed up. Where do you put the number? So that'll take me 15 seconds to write it down, and it's going to prevent me from getting confused. Okay, so T is time, that is in years, and Y is the amount of strontium, so I'm going to say strontium in grams. Now I'm not going to get confused. What is the initial mass? Can anybody tell me just like that? What is it? What is it? It's 10. It's that number that's going to be right there. So we're just going to say 10 grams. Please make sure that you label it. Okay? How much of the initial mass is present after 80 years? Guys, look. My 80 is going to go in for T, or it's going to go in for Y. I have to figure out which one. You tell me, which one is it, everybody? It's T. So you're going to have Y equals 10e to the negative 0.025 times 80. You guys, is the amount of strontium going up or is it going down? Somebody tell me. It's going down. How do you know that? Your K is a negative. Good. Grab your calculator. Everybody go 10 second ln negative 0.025 times 80. Close it off. Hit enter. They'll tell you where to round. Let's go 3 digits. So we'll go 1.353. Your label is grams. That's your answer. Okay. Question C. When will half remain? Okay. So they're asking when. So I know they're asking for time. So I'm going to go 10e to the negative 0.025 t is equal to. Now, somebody tell me what number I put on the other side. Put 5. Yep. If I start with 10, half of 10 is 5. Okay. Hey guys, freeze for 2 seconds, will you? Nobody's doing anything wrong. I'm not mad at all, okay? If your quiz score was low, going through the process of this lesson, the solving, am I stuck, the converting, the checking, it's going to help you to understand your quiz better, okay? So just know that this can actually help your confusion on your quiz. Okay, I know that I'm going to have to do what? Everybody in the room tell me, what am I going to have to do? Convert. Do I do that now? No, because I'm not what? I'm not stuck. What do? Get rid of the 10, right? So you have e to the negative 0.025t is equal to 5 divided by 10, which is 0.5. I'm stuck now, so I convert it. So it's log base e of 0.5, pardon me. So that's ln 0.5 is negative 0.025t. To solve for t, I divide. So it's ln 0.5 divided by negative 0.025. Okay, grab your calculator. ln 0.5, close it off, divided by negative 0.025, hit enter. We're going to go 2 digits, and the answer is 27.73, and this is all in, thank you, years. Done. Okay. All right, it's going to start getting just a little bit tougher. Okay, look at the next one. The number of bacteria in a culture is given by this model, where t is time in hours, and n is 280 when t is 2. What is the initial amount? Okay, everybody look at this equation right here. I want you to compare that equation to the 2 previous examples we've just done. Can anybody tell me anything that's different about this equation compared to the last ones? And I don't want you to say, oh, you start with 250 here and you started with 80 there or whatever. It's not what I'm looking for. Can anybody see?
There's no rate.
There's no rate. You're exactly right. We don't even really have an equation. Look what we know. We know y equals PE to the RT. Okay, we know PERT. And we know that the initial amount is what? 250. That's all we know. We don't really have a formula. Okay? Okay, everybody listen right here for just a second. Okay, need you to listen. This is important. Okay? I'm conducting an experiment. I have a petri dish. I start with 250 bacteria. Then I put it under certain conditions, and we're talking about days on this, hours. 1 hour goes by, 2 hours go by, 3 hours go by, 4 hours go by, 24 hours go by. So at some point in my experiment, I'm going to stop and I'm going to grab that petri dish and I'm going to put it under the microscope and I'm going to count how many bacteria are there, and I'll know how long has passed, and that will tell me, okay, that will tell me how fast it's growing or how fast it's decaying. So I need some data in the middle of my experiment to find the rate. Who says I understand what you're saying to me? Okay, so here's the data right here. I'm going to have 280 bacteria when 2 hours have passed. Okay, off to the side, I want you to write this down. Okay, this is super important. Step 1, step 2, step 3. It's very simple. Okay, step number 1, find your K. Step number 2, find your model. That's the equation. Step number 3, answer the question. Look how simple that is. Okay, find your rate, come up with the equation, plug in where you need to. Okay, so question A is easy. The initial amount is right there. I can see it. So the answer is 250 bacteria. Okay, question B, what is the value of K? Well, that's my first step, is to find the K. You guys, can anybody in this room tell me if K is going to be positive or negative? Can anybody tell me? It's going to be positive. How do you know that, Jackson?
It goes from 250 to 280.
Yeah, it's increasing. 250 to 280 increasing. I know my K is going to be positive. Okay, watch this and stick right with me, okay? Everybody write y equals PE to the RT. or, you know, CE to the KT, it's all the same. Actually, write PERT, and then underneath that, I want you to write y equals CE to the KT. We could do an R and a K are the same thing, but on these problems, you're really supposed to do a K, and I don't want to confuse you, okay? So I know I start with 250. I know my E is going to be an E. I know that I'm looking for K. So now I need a T, and I need a new amount. Well, that's right here. So when time is 2, the new amount of bacteria is 280. Who says I'm with you? Give me some feedback how we're doing. Great. What am I going to ask you right now? Are you stuck? What's the other question? No, what do? You divide by 250. So now I have E to the 2K is equal to, if you go 280 divided by 250, you get 1.12. That's a nice number. So if it's nice, let's write it, the decimal, instead of leave it as a fraction, okay? What am I going to ask you here, everybody? Talk to me. Are you stuck? What's the answer? You are. I know I'm going to have to convert because my K is in the exponent. So I convert it. Log base E of 1.12, that's ln 1.12, is equal to 2K. Solve for K, so it's ln 1.12 divided by 2. Okay, grab your calculator. And I want you to go ln 1.12, close it off, divided by 2, and I want you to hit enter. It's pretty typical to go 4 digits on that value of K. So now we're going to go K is wiggly equal sign. What does wiggly equal sign mean? Approximately, yes, 0.0567. I want you to listen. My next question is to come up with the model, okay? Everybody go, y equals, I know I start with 250, e to the k, which is 0.0567 times t. Couple of things I want to say right here. Now we're back to the first question. You understood all that I just did, and now we're back to the first question. We've got our equation. So they're going to give me a number, I'm going to put it in for t, or I'm going to put it in for y, and I'm going to find the other variable. But listen, is it okay if I use 0.0567? That exact number. It's not okay. Sam, why is it not okay? It's an approximation, and then when we do all of this manipulation to it, it's going to take a small error, it's going to make it bigger, bigger, bigger. So to prevent that, because I want my number to be exact, what do I have to do right now? Store it. Yep, everybody hit store, enter. Okay, so step number 1, find your K, we did it. Step number 2, find the model, that's the y equals 250 e to the 0.0567 t, and now all I have to do is answer the questions. So this model right here is what I'm going to use to answer all the rest of the questions. What is the population after 5 hours? Well, that's easy. It's going to be y equals 250 e to the 0.0567 times 5. Grab your calculator and go 250, second, ln, 5, membar, enter, close it, enter. We're going to go to the nearest whole, and we're talking about bacteria, so it's 332 bacteria, and we're done. Okay, next one. Find the time required for the population to double. So guys, this is just like the first question. It's 250 e to the 0.0567 times t. On the left-hand side, I do not put a 2. What do I put? Everybody tell me. 500. Yep, double 250, which is 500. Good. What do you do right here? We keep doing the same thing. What do I do? Everybody talk to me. Divide by what? Everybody, come on. 250. Thank you. So you have e to the 0.0567 t is 500 divided by 250, which is a 2. Convert it. ln 2 is equal to 0.0567 t. To solve for t, it's ln 2 divided by 0.0567. Do not use 0.0567. You have to hit that membar button. Okay, so everybody go ln 2, close it off, divided by membar, enter, enter, and you get, we'll go 2 digits, and it's 12.23, is it days, everybody?
Hours.
Hours, thank you. Okay, now freeze right here for a second. Freeze right there. It's totally checkable. Okay, don't touch your calculator. Let me show you something. See that pink stuff I just highlighted? This is already stored in as A. So I can't store this guy in as A, but I can store him in as B. So if you hit store, then go right, and then go enter, I've got that number. Now I'm going to put the 250, the pink stuff. So I'm going to go 250, second, LN, membar enter, membar right enter, close it enter. I got 500. I just checked it. Okay, so I initially stored this in as A. So I took that 12.23, stored it in as B, put that in, got 500. I know I got it right. Okay, who says gotcha? Let's see. Okay, great. Okay, you guys, question E. So I think this question is kind of weird, just so you guys know. The maximum capacity of bacteria is 2,000. If this is this a good model for the situation? If so, when will the bacteria count reach 2,000? Okay, so just draw an XY axis right here. And here's our equation. Our equation is y equals 250 e to the 0.0567 t. So what does the graph of this look like? Well, it's an exponential. Some of you need a refresher what an exponential looks like. I can tell from the quiz scores that I was grading yesterday. So basically an exponential looks like that. If t is 0, then you're going to hit right here at 250. Okay, so basically it's going to look like that. And it's going to go up and up and up. It doesn't go completely vertical, but it does go very steep. Okay, so don't make it look vertical. And then you've got an asymptote. Okay, so the number of bacteria is a y value. So guys, say 2,000 is right here. And say you have a limit right there that the number of bacteria cannot go above 2,000. Is this a good model? This goes up and up and up and up forever. So is it okay to have a limiting y value if you've got an exponential equation? No. So is this a good model? No, it's not a good model. And I would say exponential graphs increase forever. There's no limit. Something like that. Okay, question 4. This is really probably what it's going to look like. Okay. In a research experiment, a population of 100 fruit flies is increasing according to the law of exponential growth. After 2 days, there are 300 flies. How many flies will there be after 5 days? Okay, off to the side, I want you to go step 1, find your K. Step 2, find your model. Step number 3, answer the question. See where it says model? I want you to write this down. Y equals CE to the KT. When you write down your model, if you look at all the models we've been working with today, here are the only numbers that they have written in. They have a number written in for the C, and they have a number written in for the K. So do you see how I've highlighted the C and I've highlighted the K? The T is going to stay a T in the model, the E is going to stay an E, the Y is going to stay a Y. The only numbers you'll pull in are C and K. All right, here we go. Everybody write down Y equals CE to the KT. 100 is how much we start with. Okay, I know my E is going to be an E. I know I'm looking for K, so I'm going to leave my K a K. I can only have one variable in that equation because I'm trying to solve for that variable, K. So I have to have a T and I have to have a Y. You guys remember that's the place in your experiment where you stop and collect data, and that's right there. So that's going to help me find the rate at which it's growing. So after 2 days, so I'm going to put a 2 in for T, there are 300 flies. I know I'm going to have to convert, but not right now because I've got that 100 that I've got to get rid of. So I've got e to the 2k is equal to 300 divided by 100 is 3. Now I'm stuck, so I convert it. So it's log base e of 3, that's ln 3, is equal to 2k. To solve for k, I divide ln 3 divided by 2. Okay, grab your calculator. It's important that you put this in your calculator, okay? Everybody go ln 3, close it off, divided by 2, hit enter, and you have k is approximately 0.5493. I want everybody to hit store enter. So I've just stored it. Step number 1 is done. Step number 2 is taking this model, putting a value in for C and a value in for K. So everybody go y equals 100 e to the 0.5493 times t. That's easy. Now answer the question. How many flies will there be after 5 days? Guys, do I put my 5 in for y or do I put it in for t? Somebody talk to me. T. So it's just going to be y equals 100 e to the 0.5493 multiplied by 5. Don't use 0.5493. Use membar. So everybody go 100 second ln 5 membar enter, close it, enter, and we're going to go to the nearest whole. So the answer is 1,559 flies. Disgusting. That's really the gist of it. I think if you feel good up to this point, you're going to feel good about the whole lesson. Half-life is a little tricky, but you know, I feel like it's not that bad. You're going to be fine. Who says I feel good so far? I need some feedback from you. How you're feeling? You okay? You okay so far? Okay. Question 5. First thing I want to do is talk about half-life. So everybody just put your pencils down. I want you to listen for just a second. I'm sure you've learned this from science, okay? Say you have some carbon-14. Say you have, let's make it easy. You have 100 grams of carbon-14, and it's getting smaller, smaller, smaller. It's decaying, okay? So after 5,715 years, your 100 grams goes down to 50 grams. Then after another 5,715 years, your 50 goes to 25. The next 5,715 years, it goes to 12.5, and then 6.25. So it cuts in half, in half, in half, in half, in half every 5,715 years. Who says gotcha? Raise your hand. Okay, great. Off to the side, write these steps. Step number 1, find your K. Step number 2, find your model. Step number 3, answer your question. It's simple, very simple steps. Okay, the half-life of carbon-14 is 5,715 years. Find a function modeling carbon-14 decay. They want the model. They want the equation. Okay, so everybody write down y equals CE to the KT. I know my first task is to find my K. So leave your E in E, leave your K a K. Now I have to have a number for Y and for C and for T. Well, I know the half-life is 5,715. That's a time, so I'm going to put that here, 5,715. Now, I'm all out of numbers, but I still need an initial amount and a new amount. Does anybody have any advice on what we could do with that? Make it up. Make it up. That's exactly what I do, Jackson. And I choose the easiest number I could think of. And for me, most of the time it's going to be 100. Okay? So if I start with 100, now everybody better know this answer. And one half-life cycle has passed, how much do I have now? Everybody tell me. Half as much, 50. This should look really familiar. I know I'm going to have to convert. My K is in my exponent, but I'm not stuck. So I divide by 100. So I have E to the 5,715K is 50 divided by 100, which is 0.5. Now I'm stuck. So I convert it. So it's ln 0.5 is equal to 5,715K. To solve for K, you divide. So it's ln 0.5 divided by 5,715. Okay, grab your calculator. Everybody go ln 0.5, close it off, divided by 5,715, and you get K is approximately, we'll go 4 digits, negative 0.000. I'm actually going to go 5 digits, 1, 2. okay? Why is it negative? Is that wrong or weird? Because it's going down. It's a half-life. It's decreasing, so it should be negative, okay? All right, so now I need my model, okay? I want you to remember this, guys. When I write down this model, my C and my K are the only numbers I put in. But they didn't tell me what I started with. You can't make it up on the model. I just made it up to find my K. So if I don't know how much I started with, I'm just going to leave it alone. So it's y equals CE to the negative 0.00012 times T. That's my model. Okay, I'm done. Question B. In 1947, jars containing the Dead Sea Scrolls were found by an Arab herdsman. Analysis indicated that the scroll wrappings contained 76% of the original carbon-14. Estimate the age. You guys are asking me for age, so I know they're asking me for time. So everybody put your equal sign. On the right-hand side, go E to the negative 0.00012 T. They still didn't tell me how much I started with. But I do know that I'm trying to find out when 76% is left. So what do? I make it up again. So I'm going to say I started with 100, like 100 grams or something. And if 76% is left, can anybody tell me what I put over here? It is 76. Do you see why you use 100, right? 100's easy. 76% of 100 is 76. I am not stuck, so I divide. So I have e to the negative 0.00012 t is equal to 0.76. Hey, freeze right here for just a second. We did not store in that value of k. I forgot to tell you to do that. So hopefully that's on your calculator. Everybody hit store enter. So now we've got it on there. Okay. Now I'm stuck, so I convert it. So it's ln 0.76 is negative 0.00012 t. To solve for t, it's ln 0.76 divided by negative 0.00012. Grab your calculator and go ln 0.76, close it off, divided by membar, enter, enter, and I get, we'll go 3 digits, and it is 2,262.73, and this is years. Don't clear your calculator, okay? We're going to check it. I'm going to store that in as B. So everybody go store, write, enter, and then let's put in this right-hand side, and the exponents are going to be A times B. So everybody go 100, second, ln, membar, enter, membar, right, enter, enter. I got 76. I did it right. Okay, question C. Estimate the age of a fossil that has 40% of its carbon-14. You guys, it's the exact same thing. Look right here. It's the exact same setup, except my 76 is going to be a 40. So everybody go 40 equals 100 e to the negative 0.00012 t. I'm not stuck, so I divide. So e to the negative 0.00012 t is equal to 0.4. Convert it, ln 0.4 is equal to negative 0.00012 t. To solve for t, ln 0.4 divided by negative 0.00012. Now that negative 0.0012 I have stored in as A. So everybody go ln 0.4, close it off, divided by membar, enter, enter. We're going to go 3 digits. And the answer is 7,554.819, and that would be years. You can store that in as B. Come over here to the right-hand side. The exponents would be A times B. You should get a 40. Okay? Okay, example 6. Off to the side, let's write this down. Find your K. Find your model. Answer the question. The half-life of a substance is 2,300 years. 20 grams are present now. When will 5,000 years, how much will be present after 5,000 years? Guys, listen, people start getting confused and they start putting in like the 5,000 right now. The 5,000 is the question. I'm not going to deal with that until I'm all the way down to step number 3, okay? Everybody write down y equals CE to the KT. I know that I'm looking for K, so I'm going to leave my K at K. 20 grams are present now, so I'm going to do 20. I know the half-life, which is a time, is 2,300 years. Somebody tell me what to put on the other side. If I start with 20, then 1 half-life cycle has passed. I'm down to 10. Divide by 20. So E to the 2,300K is equal to 10 divided by 20 is 0.5. I'm stuck, so I convert it. So it's ln 0.5 divided by 2,300K, divide, K equals ln 0.5 divided by 2,300. Grab your calculator and go ln 0.5, close it off, divided by 2,300, hit enter, and we're going to go K is approximately negative 0.0003. Everybody hit store, enter. Step 1 is done. Now I'm going to do the model. Here's my model right there with a number put in for C and a number put in for K. So my model is going to be y equals 20 is how much I started with, E to the negative 0.0003 times T. How much will be present after 5,000 years? Do you see how I haven't touched the 5,000? That's probably the number one error, is people start putting numbers in that they're not supposed to. So the 5,000 is the question. You tell me where to put 5,000. Is that T or is it Y, everybody? It's T. Good. So it's going to be y equals 20 e to the negative 0.0003 times 5,000. Okay? Everybody go 20 second ln 5,000 membar, enter, close it, enter, and we're going to go 3 digits, and it's going to be 4.432 grams. And I'm done. Okay, I want to talk for 2 seconds about population. Look right here for a second. Just look and listen. Think of the population on the earth. Okay, look right here. Is that a good model for the population on the earth? It's not. It's not a good model. Can somebody tell me why? How come you shook your head and said no? Yeah, it can't be an unlimited amount of people, right? We only have so much space, we only have so much food and water and stuff like that. So a population is a logistic model, and this is what a logistic model looks like. Look, flattens out, because there's only so much capacity that we can handle, right? So that's what we're going to deal with right now as a logistic model. Okay, so we look right here. Now they give us an equation, which is nice. The function f of t is equal to this equation, describes the number of people, f of t, who have become sick with the flu after 2 weeks of initial and town of 30,000 people. Everybody go t equals and f of t equals. So t stands for weeks, it's time, and f of t is the number of people that are sick. Question A, how many people are sick when the flu begins? You can't just look at this one and say, oh, here's the answer. It's not 30,000. 30,000 is how many people are in the town. So everybody go f of 0. Why am I doing 0? Because initially 0 time has passed. Okay, so it's going to be 30,000 divided by 1 plus 20 e to the negative 1.5 times 0. Okay, I want you to grab your pencils and I want you to put parentheses around the bottom, because when you put this in your calculator, you have to tell the calculator both of those things are on the bottom. So everybody go 30,000 divided by parenthesis 1 plus 20 second ln negative 1.5 times 0, close it off, hit enter, and we're going to round these to the nearest whole, all of them, because it's people, so it's 1,429 people. Okay, question B. How many people are sick by the end of the 4th week? Well, it's the same thing, except for instead of a 0, you're going to put a 4. So everybody go, f of 4 is equal to 30,000 divided by parenthesis 1 plus 20e to the negative 1.5 times 4. I want to show you a trick, okay? Everybody hit the up arrow on your calculator, and I want you to scroll to the right until you're on top of that 0 you put in, and then I want you to replace that with a 4, and then hit enter, and there you go. So you don't have to put the whole thing in. So the answer is 28,583 people. Okay, question C. Find the time when half the population is sick. You guys, now I know they're looking for T. So on the right hand side, go 30,000. On the bottom, 1 plus 20e to the negative 1.5 times T. Now I have to have a number for the right hand side or the left hand side. Somebody tell me what that would be. 15,000. Good, half the population. Okay, now I'm going to show you a trick on this. Okay, everybody freeze right here. What do you do right here? Like what's the next step? I don't know why I can't get it in your brain. I know as soon as I do one thing, you're going to know. Say it again. How do you do that? Put a 1 underneath, and now everybody's going to see that the next step is to cross multiply. For some reason, if you don't have that 1, you just can't see it. You cross multiply, but freeze for just a second. Freeze right here. I'm going to show you an awesome trick. Do you see this 15,000? And do you see how it goes perfectly into 30,000? I'm not going to distribute the 15,000. I'm going to cross multiply, but I'm not actually going to distribute. Okay, so watch. Go 15,000, and then go parenthesis. What's across from it? 1 plus 20e to the negative 1.5t is equal to 30,000 times 1 is 30,000. Do you see why I didn't distribute that? What can I do now to make it super clean? Say it again, Sam. Divide by 15,000. Yeah, so I have 1 plus 20e to the negative 1.5t is equal to, bless you, lots of people on the quiz right here, there was a problem similar to this. They put 15,000. They took 30,000 and subtracted 15,000. You're supposed to divide. That's a 2. I know I'm going to have to convert. Do I convert right now?
No.
What do I do first? Move your 1. So you have 20e to the negative 1.5t is 2 minus 1, which is 1. Do I convert now, everybody? No. What do I do? Divide by 20. So now I have e to the negative 1.5t is equal to 1 divided by 20. Everybody hit 1 divided by 20. 1 divided by 20 is a nice number. So let's go ahead and just write that as 0.05. If it was not nice, leave it as 1 over 20. Okay, but it was nice, so we don't have to. Convert it. ln 0.05 is negative 1.5t. To solve for t, it's ln 0.05 divided by negative 1.5. Grab your calculator. ln 0.05, close it, divided by negative 1.5, hit enter. We're going to go 3 digits, and it's going to be 1.997. This is time, and it's in weeks. Label it. Okay, we're going to check this one. Okay, freeze right there, hit store, enter, and we're going to put it right there. Okay, you could go up. Everybody can hit up many times until you're on top of that. Then go over to the right where you put in the 4. And instead of that, hit membar, enter, then hit enter. There's your 15,000. So I just checked it. Okay? You now know everything you need to know for test 3. So from now until Friday, it's just cleaning everything up and refining everything, okay?